All right, question 14. We want to use graphing guidelines to make a complete graph. Below we can see we have some answer choices, so we're going to keep it simple. We're going to find a domain, see if we can eliminate some answer choices, and then find the derivative and the maximum point. You could easily just plot some points. We're going to use some of the calculus aspects. So when we deal with the square root, whatever is underneath the square root cannot be less than 0. We cannot do the square root of a negative. And so to find the domain, we start out with whatever is under the square root, x plus 1. And that has to be greater than or equal to 0. We would subtract 1 and we get that x has to be greater than or equal to negative 1. So any number from negative 1 and greater to the right will be in our domain. So based on that, I can look at some of these graphs and see how some of them are continuing to go left and run off the page. I would eliminate this one because this is going past negative 1. And then I would also eliminate B. It's going up, but it's also going left. If we zoom in, you can see it looks like these are counted by, I guess, halves, because 1, 2, 3, 4 to get to 2. So it's a half, and then 1.52. So here, negative 1 would be, and this graph looks like it's going to just continue off the page. So these two would be eliminated based solely upon the domain. All right, next I will find the derivative. I'll do product rule. You can rewrite this if you want using some algebraic methods. This function would be equal to the square root, and you have to square this and put it under. So you have like x squared times x plus 1, and you can distribute that. And then you would only have to do chain rule, but just in case you're not familiar with that or don't follow it, we'll just do product rule. But I'll show you get the same. 1 first times the derivative of the second. 1d2, so 1/2. So I'm looking at this as x plus 1 raised to the 1/2 power. So I do 1/2, 1d2, subtract, so negative 1/2 as exponent. So 1 first function times the derivative of the second plus a second times the derivative of the first, and then simplify. This would give me x on top over 2. This negative exponent will come down. It's half is the square root, so I'll get 2 square roots of x plus 1. And then plus square root of x plus 1. And then common denominator, I can multiply top and bottom over here by 2 square roots of 2. Sorry, 2 square roots of x plus 1. This will give me a common denominator. And then when I multiply this times itself, it will get squared and get rid of the square root, distribute the 2. So I would have an x plus, this will be 2 times x plus 1. And then finally we would get 3x plus 1 over 2 square root of x plus 1. So here's our derivative. Once we find our derivative, we would set it equal to 0. Remembering from our domain, we're only going to use numbers from -1 and beyond. a square bracket, -1 to infinity. We'll set our derivative equal to 0. Multiply by the denominator, that will give us 0 equals 3x plus 1. And then solve for x, subtract 1, divide by 3, so we get x equals -1 over 3. So -1 over 3 would be our critical point. Make a number line, -1/3. So this is negative infinity side, positive infinity side. Pick some numbers left of 1/3. Now, I put negative infinity. Not really sure why, because we can only go to -1 based on our domain. So something negative, I would just say a -1/2 is what we can test. And something on the right side, 0 would be the easiest. So I'm just looking for the sign. And I'm thinking if I plug in a really small negative number and I multiply it, this will give me 3/2. I'm going to use a half. Might need to work it out. 3 -1/2 plus 1, 2 square root -1/2 plus 1. Okay. So this would be 3/2 plus 1. This will come out negative on the top. And then this is positive. Square root is going to give me a positive. So I have a negative divided by a positive, which is going to give me a negative. So this section is negative. Would be decreasing on this side. And then if I plugged in 0, 3 times 0 is 0, we get a 1. 0 here, this is all positive. So this would be positive. Would be increasing. So that tells me that this -1/3 would be a minimum. It's decreasing to increasing. All right, and of the two graphs, the only one out of the two that we still have left, C and D, D is the one that goes from decreasing to increasing. So we would have a minimum at -1/3.